Okay, so in this video we're going to be writing some macros for error checking and logging, which is very important when you're developing a library. So what we're going to do is we're going to write a macro. A macro is basically a fragment of code that has been given a name. So we're going to write check LE for checking if eval1 is less than or equal to eval2 and pass them in as parameters to this macro. Backslash for saying that the declaration continues onto the next line. Here we're going to check if this expression is falsified. So we're going to check if val1 is less than or equal to val2 is not satisfied. Now we need to, if it is, that whole expression is satisfied, then that means we need to print something out. So we're going to include stdio.h, so we can use fprintf. Now we're going to print to standard error, where we could just pass in a message check failed with a new line. Okay, so now we're going to go to the main function where we can check what we wrote was correct. So let's check if 10 is less than or equal to 6. And we do that by saying check LE. Check LE. So we're also going to include the logging.h file. And also going to return 0. Now we don't want the program to terminate, so we're just going to make it wait for some user input by doing int I, cin insert into I. See if it works. Alright, it worked. Alright, so now we have this check LE, but there could be many other operations. So doing this would be pretty tedious. So we can make a helper macro. We're going to say check op, which takes in the value as well as the operation. So this will do the if statement for us, where we replace the less than or equal to with op, and with check LE we just replace the implementation of that with check op, and that would scale a little better. So let's check if that works. Alright, so it worked. So we want to add a couple more operations. One for checking if something is equal to another thing, EQ, and then another for checking if something is not equal to something else. This should be NE, not NQ. Now when we print out our string, we want to have some common properties in the string, such as the file name and the line. So we want it to be handled by a class so that it's more consistent when we call it from a different macro. So we're going to have a constructor here. And it's going to take in a message and a destructor. Now we want to implement these methods in the CPP file, but for convenience I'm going to just say everything below this line should be in the CPP file, just to make things a bit clearer. Okay, so we need to include string because we're using std string, and we need our private member variable for message. So we're going to go std string message with a trailing underscore, because that's how I denote my private member variables. Just going to implement these constructor and destructor. Now the preferred way of initializing the member variables is by doing this, and not in the actual body of the function. So we don't want to directly print out in the check_op macro. We want to call our log message class instead, and without assigning it to anything, because we're just interested in the destructor. Because as soon as it goes out of scope, which is as soon as it exits the if statement, it's going to call this destructor. So we can put our print statement in the destructor and just format our string here. So we want to call our private member variable and grab the C string from it because we're using a C function. fprintf is a C function. And now we just want to pass in a check failed with a new line into the constructor. So this should work, I think. Right, check failed. Okay, so now we want to run this again, and we want it to be more verbose. We want to print out the operation that failed. So what we can do is convert check failed into a string, that going std string, and then passing that in. So now we can concatenate more strings, and we can do a hashtag val1. So the hashtag means that we can convert the macro parameter into a string, whatever the value of value1 was. So now we make our expression into a string so that we can see what expression failed. And that should work, so give that a go. Cool, so we get 10 less than or equal to 6 failed. So we want to make string concatenation a little bit easier. That way we could do this by including ssstream. So we want to be able to do an insertion operator and pass in strings into the log message class this way. We can do it by making log message derive from std o string stream, o string stream, and then that means we don't need to have the parameters to log message. We could just pass it into the class using the insertion operator. So we're just going to change all the plus signs into insertion operations, and it should do the exact same thing. Now this also means that we don't need to store our message as a private variable, and we don't need it in the constructor as well. So you can get rid of that. And when we print it out, we call the base class's string method, which returns the string that was formed by just going str. Okay, so we get the same thing, so it works. So just to fix up a couple things, stdio.h should be in the CPP file. And also, some of you might encounter a bug where the output of the log message class would be some rubbish for the first insertion. We can fix it by doing .flush. This makes sure it works. It returns like an OStream object. So and we get the same thing. So if it didn't work for you before, then you should do that. So now we're going to run the program again, and we realize that because this is a fatal operation, if it doesn't work, then it should abort. But right now it doesn't do that. So what we're going to do is make a class called logMessageFatal that derives some log message, and we're going to have our own implementation of the destructor, our own customized implementation of the destructor. So just going to define constructor and destructor again. but for log message fatal, put it in the CPP file. Now we should note that when you derive from a base class, the derived class's destructor gets called first, and then the base class's destructor. So it happens in the reverse order of construction. So that means if we were to put abort in the derived class's destructor, like so, that would be called first before it calls the print statement in the destructor of the base class. So that wouldn't work. And we could demonstrate this by going log message fatal in check op and running that. And we don't get any statements. So the way we could fix this is we need the derived class to have access to the print statement. So we can make some sort of protected function, meaning that derived classes have access to whatever is protected in the base class. We're going to write a function called print log message, which is basically what we're just going to put our print statement in. So we could just copy and paste what we had in the destructor in there, and we could just call this function in the destructor instead. Now the derived class has access to it, so we can call it here as well. And this ensures that something is printed before you abort. So I think that should work. Just give that a go. Yep, works. So we want to have different levels of severity. Fatal is one of them, but there could be more. So we're going to define an enum called severity. And first one could be info, which isn't really that important, but warning might be a bit important. We could have error, which is not good, and then fatal, which is fatal. Now, error could be already defined in Windows, so we need to undef it by going undef error. So if that was a problem, then you need to that would fix it. Now we need to store the severity as a private member function of log message, so that we could later on print it out as part of the error log. Pass it in as an argument. And initialize it here. Okay. So in the derived class, we also need to call that constructor because it has an argument now. It won't be called by default anymore. By doing this, we pass fatal in. Now, in our printing, we need to print out the severity as well. So we're going to pass in the severity, not fatal, the severity, which is the severity underscore. And this is an enum, so we're going to use it as an index to a string. And the string is going to be I for info, W for warning, and E for error, and F for fatal. So this would output a char. So that means we need a C here instead of an S to format it. Let's see if that works. Okay, so we get an F here, so that's what we want. But this can be a bit ambiguous if we don't know what f means. So if we want to make it a whole word, we could have a array of severity names. So const a city string and call it severity names. Now we need to pass into the number of severity levels. So there's 4 here. We could hard code it, but what I found was pretty good was if I specify the num severities as the last enum. So that works pretty well. Now we specify all the strings as separated by a comma and curly braces. Actually, I think I want info in capitals, warning in capitals, error and fatal. Now here, we could just specify severity names, and this is no longer a char, it's a string, and also we need to get the C string from the string. So I think this would work, and we get fatal, so that's what we want. So now we also want to print out the file name, the function name, and the line. So we're gonna put in here const char star the file name. It's gonna have const char the function name and the line, all as member variables. We need to update the constructor to take in these arguments so we can initialize them. Alright, so we want to initialize these with default values, the file name, function name, and the line. We can do this using a preprocessor macro, which is underscore file in capitals underscore. Similarly, we have a function one and the line one. So that should grab the file, function, and line that we're currently on, and as a string. So now we also want to implement a constructor for the log meshes fatal that takes in all these parameters as well. We're going to use constructor chaining to call the base classes constructor. Now we want to also print out the file, function, and line and format it here. So %s, and %d. I'm going to put those in quotes, and Now this is an std string, so we don't need to grab the C string from it because it's already in the correct format. Let's see if it works. Alright, cool. So we get the severity, the file, the function, and the line, and then the message. So it's working as expected. So I've realized I've made a couple errors. First one is this is log measures fatal. We already know the severity is fatal, so we don't actually need to pass in. Second one is here. This is the wrong file. It says login.h, but it should be main.cpp, and the function should be main. So we need to fix that. So let's just solve the first problem here. We just need to get rid of severity as an argument here, and in the implementation as well. And for the base constructor, we just pass in fatal. Now, check LE is essentially gets replaced with this line. So if we were to call the file, function, and line here instead, these macros will expand to the file and function and line within the main file. So, which is what we want. So running this, we should get the correct file. So we got main.cpp and the function is main, so that works. Alright, so let's just do some cleanup. We don't need this bit here. So don't get rid of this. Also don't need the one for the derived class as well. Check if it works. Alright, so it still works. Okay, so I realized that we don't need an std string here. We could just use a const char star. So that means we don't need this to grab the C string anymore because it's in the correct format already. Check that works. Yep. So let's just test if 1 is less than or equal to 6, which it is, so it shouldn't really do anything and print out nothing. Yeah, so that works. Okay, so we're going to try something new. It'll be useful if we can have this log macro and pass in some severity, like info, and then insert into it whatever information that we want, and then it will print out for us. So we can also do it with warning and any other severity. So here we could say something like running out of memory. So let's implement this. So let's define a macro. How should I define log? Pass in a severity. And here's the interesting part. We are going to call log underscore double hash and then the severity. So the double hash is the preprocessor operator for concatenation. So I'll show you how this works, but first let's define log info. And we want to be able to log whatever message that you pass into it by using log message. Now we need to specify the file, function, and line. So remember that a single hash converted the macro parameter into a string. Well, if you have another one that is double hash, now we can use it to help build our macro definition name and dynamically swap it out with different values of severity, and then call different macros based on the severity name. So we can call log info and we can call log warning. We can call log error as well. Now for log fatal, we need to call log message fatal class instead. Okay, so this should work. No. Oh, it should be spelled it wrong. Info. Okay, try that out. Yeah, so we get info and warning with our messages that we specified. And so it's main 7 and main line 8. So we just check if that's correct. Yeah, so it's line 7, line 8. So that's what we want. So that's pretty good. So let's just clean up some stuff. We don't need that. And just gonna add some more check operations. So we're gonna have a less than. LT for less than, and a GE for greater than or equal to, and a GT for greater than. Now we're going to add a special check that's commonly used, check not null. So we just need one parameter, and we're just going to call our check not equal to check NE. So we'll check if val is not equal to a null pointer. Now we want to check if this works, so let's define a void star pointer equal to null pointer and check if it is not equal to null, which it is, so it will fail. Alright, so give that a go. Yeah, so we get check failed, pointer does not equal null pointer. So what if we want to pass in our own customized message, say insertion operator, and then pointer must not equal to null? This would actually work, and I'll show you why. Our check not null here is actually a check not equal to, which is a check op, and check op expands to this if statement, which calls log message fatal. And log message fatal is a log message, which is actually an O-string stream. So essentially what we have is an O-string stream, so we can pass in messages. So this expands to this if statement, and what happens is this line appended at the end will look like this when the compiler expands it out. So this should work. So let's give it a go. Yeah, and so at the end there we get pointer must not equal to null. So what if we want to have debug versions of this? Because doing these on a loop can get pretty expensive, so we want to have debug versions. So we can do that by saying if not in definition, so if end def. End debug means not debug. So that sums up meaning we are in not debug. We're not in the debug mode. So in this case, we want all our macros to work. And we will want to denote these as debug by saying, by prepending a D to these macro names. Now, if this condition isn't satisfied, then we still want the debug macros to work. So we're going to say else and end if, and within this is our release mode versions of these macros, where we can basically have them there as duds that don't work, but they should be there so that we don't get an error. So let's test this out. First, let's get rid of this message and call our debug. So this should work the same way. Yep, so it works the same way. Now let's define end debug and see what happens. So we should get nothing. So end debug means we're in some release mode, so that means we don't want those checks to work. With Visual Studio, if you define end debug and then you get this grayed out effect, so that means those are no longer active, but when you take it out and it's not grayed out, then it means it's active. So I thought that was a pretty cool feature. Alright, so let's define end debug again, and this time let's pass in a message into a custom message, pointer must not equal null, and see if this works. So we get an error because our dud isn't an OStream object. So the way we can fix this is by defining some dudstream macro where we can say if false, so that this is always going to be true, then log. Now we're just going to pass in a severity, just say fatal. It doesn't really matter because it's never going to execute. So we're just going to use this for every dud debug check operation, and this should fix it. Give that a go, and we shouldn't get an error now. So that's about it for this video. Now we have some really helpful tools for debugging and error logging.